What if I told you guys that a tiny misconfiguration could bring down your entire network? Endless loops, network outages, and chaos, all because of what? Uh, an unmanaged layer 2 network. But don't worry, guys. For this problem, Cisco gave us a solution, STP. In this video, we will break down the whole idea of STP, all the fundamentals, and each topics that you can see in here. So we will break down each topic to keep your network safe from loops. Welcome back to TECHDIVE-HUB. I'm Harun Hamdar, and today we are diving deep into Spanning Tree Protocol, also known as what? STP. STP is one of the most important topics in layer 2 network, or we can say network layer 2 topologies like switches, and it is so much important, such as it prevents loops in our network, layer 2 networks. Whether you are trading for your CCNP and core exam or whether you are configuring it, it is crucial to know about what's STP, and it's so much important to know about STP. So let's dive into it and start our first topic, STP. Spanning tree, also known as STP, is under the standard of IEEE 802.1d. What does it do? It prevents loops in our network. When we configure redundant link, we expect that to improve reliability and redundancy in layer 2 networks. But we create what? Loops, network loops. So Spanning tree gives us the ability to create a loop-free topology by identifying redundant path and disabling links that cause loop, where only active ports remain and forward traffic, and those ports that potentially may cause loops, they will get in blocking state. So let's come to STP ports and rules. Every switch in an STP enabled network play the following rules: root, designated, and also what? Blocking. Let's come to the port states in Spanning tree. We have 5 states: listening, learning, forwarding or blocking, and also disable, which STP transition between these port modes to either make the port mode to forwarding or what? Blocking. And one of the most other important topic that we have in here, how the root know that which ports are designated and which ports are what? Block ports. So by sending BPDU. BPDU is Bridge Protocol Data Unit, which is one of the most important thing in Spanning tree. And what does it do? It collect all the information that are important and needed for the root switch to identify the ports in whatever the bridge ID, cost, and ports, the disabled ports, the ports that are blocked, the root ports, and the designated ports. All the information are collected in BPDU, which is sent every 2 seconds. So let's come to the next thing that is actually important: root bridge election. All the switches build their path based on what? The connection that they have to the root switch, like the connection between designated switches to the root. So how the root is elected? The switch with the highest bridge ID is elected as the root, and we have priority and also have cost. But the first actually important thing is bridge. So what is bridge ID? So bridge ID is the combination of MAC address and priority, which is with the lowest priority, and the lowest MAC address will be elected as what? Or the lowest bridge ID with the lowest bridge ID as what? As the root switch. By default, all the switches have the same priority, but we can change those priority manually, and the lowest priority will become what? The root switch. Let's come to STP convergence. After electing the root switch, all the switches agree upon to put which port in which mode, like in forwarding state or in blocking state. And this process takes about 30 to 50 seconds. And during this time, no data is forwarded and the port is like good, we call that in pending mode, and like for 30 to 50 seconds, we can't forward any data. So for this problem, Cisco came up with an idea of rapid spanning tree protocol, which is actually so much fast, and we'll be talking about it right now. Rapid spanning tree protocol, also known as RSTP, is under the standard of IEEE 802.1w. It reduces the spanning tree converge time like from 30 to 50 seconds to what? To 3 to 2 seconds. It improved STP and to advertise some new modes for the ports, like we have alternate, which means backup port. So this was a new mode that advertised in what? Rapid spanning tree protocol. It also have backward compatibility with what? Spanning tree protocol or HTTP, and it is a great choice for modern networks. So let's come to our next topic, MSTP. MSTP is multiple spanning tree protocol. It is a standard of 802.1x, or we can say IEEE 802.1s. What does it do? So first of all, it gives us the ability to do what? To make instance. What does it mean by instance? It means groups. So by default, each VLAN send BPDUs by themselves, like each VLAN send BPDU each 2 seconds. So if we have a big network like have 100,000, even 1,000 VLANs, if it have, so what happens? Every 2 seconds, about 1,000 BPDUs are sent to each switches. So this is a problem, and we don't want our traffic to be flooded on the switch and make our bandwidth or lose our bandwidth in our network. So for this problem, they come up with an idea known as MSTP. MSTP gives us the ability to map VLANs to what? Spanning trees. Like we can group VLANs like 1,000 VLANs in one instant, and it will broadcast or send one BPDU each 2 seconds. So this is the idea that Cisco came up with, known as MSTP. It also have the feature of rapid spanning tree. It also have the feature of RSTP or Rapid Spanning Tree Protocol by default, and it is enabled by default in it. And it is, as I told you before, it is more scalable than other protocols of STP that we had. We have covered the STP whole idea and just dive into it. So I mean by diving, this is diving. So we have covered all these STP topics. So thank you guys for watching. If you found this video useful, so don't forget to press the like button and share this video, and also don't subscribe. I mean subscribe. So guys, thank you guys for watching. And also if you want to see the configuration of STP, you can watch it on the video in my description. Thank you guys for watching.